Rakesh, Principal Consultant and founder of Sketch My View. Welcome back. Talking about the important topic of data engineering and exposing a geospatial audience to these vital foundational concepts. Thanks for intervening. Take it away.
Guys, thanks for joining again, and thanks for just inviting me here again, Wilfred. Thanks, Andrew, for joining again. Appreciate it. Of course, I think Wilfred gave a couple of, a little bit of introduction, but I think I'd probably give a little bit of more introduction about myself and why this topic and why this framework here. Of course, I think I've been working in data engineering space for a long time now, consulting primarily with Fortune companies, and day in, day out, working with team of data engineers, project managers, and seeing the same problem everywhere. Initially, I didn't pay much attention to it because we were developing the data engineering work for stakeholders, and the idea was I'm seeing the same problem again and again, where the data engineers, they are onboarded to the team, and they are getting lost. No coding standardization. Of course, the couple of heavy giants in the space now, Databricks, MS Fabric, Snowflake also, and a couple of other players here. However, the data engineers, they come primarily with SQL backgrounds. Now, the more data engineers are coming from application background, but of course, that when you have a large team, you don't have any control how people are actually writing or managing data engineering life cycle, just comparing with the software engineering life cycle itself. So it just got me thinking. I've been doing the same thing again and again, working with data engineering teams, consulting with customers, and same problem. So how do we solve it? And in that space, I have seen many vendors actually they have attempted to solve that particular problem, but the problem was not eliminating completely, because the vendor, they actually came with full tools and everything, which actually was making life difficult for data engineering team. Because if you go to any company or any guy, they have a CI/CD guy, they have infrastructures guys, but the problem is they come with the technology or tech stack fully.
Sorry, Rakesh, I'm gonna interrupt just for any strange acronyms that data engineers use. You said CI/CD.
Yeah, CI/CD is continuous integration and continuous deployment. It means the software life engineering cycle is that, let's say if you have a team of 5 data engineers, and if they are working on same project, it means everyone is developing their piece of code, right? And the CI/CD stuff takes care of if I'm committing any code changes or anyone else. It's not breaking number one, it's not breaking existing system. Plus, it is not breaking anyone else's changes into the system as well. So that's where once we push any changes to any repository, in this case, let's say GitHub or similar sort of repositories, it is running continuously and making sure that my changes are not breaking the existing system. And that's very important from software engineering or any data engineering life cycle.
I feel like that's a chance to introduce this concept or the headline sort of topic for your presentation about notebook hell. How does notebook hell arise in the context of continuous integration and continuous development?
I think I'll share my screen here. So the left-hand side, what happens during any traditional notebook development or within the data engineering life cycle, many developers, they actually start creating notebooks. Let's say a new requirement came in, and they start developing that particular feature. Now, every data engineer is actually working on a new notebook in this case. So that's what that's been depicted here. So of course you have a pipeline and you have these all notebooks here. So every and individual notebooks, and the idea was, and that's the notebook hell, because everyone is actually creating notebook or notebooks. Uh, they don't have any standard. It means, let's say in the data engineering world, if you have, data schema means how your data looks like, it actually could be incoming data schema, or it could be, outgoing schema. And now the traditional approach is every developer, they keep the same thing here and there. So all the notebooks, individual notebook, they have data schema, they have SQL queries, how they want to transform data. And it actually, gets into, and I actually call it SQL spaghetti, right? And there is no coding standard here. Of course, they all are using, so Spark is the topic here. Since we are talking about spatial data engineering, it means we are talking about spatial data engineering on Spark platform, right? Everyone is using Spark and Spark SQL, and their schema is injected in the notebook itself. So,
and again, to help out guests or later listeners to this recording, Apache Sedona and Apache Spark were raised in the last episode with you. So you can go back to that recording later.
So what happens here is that, let's say the developers are there for 6 months or year on year, they just, keep on adding notebooks, and actually becomes a notebook hell. It means, let's say in a company over 5 years, I have got 1,000 notebooks. It is completely notebook hell. So it means if any new team member is joining the data engineering team, they don't know what's going on, where to find out things, and it actually becomes chaotic situation. To solve a single and simple problem, they have to struggle a lot. Of course, if the documentations are in place, that helps a bit, but it just doesn't, eliminate all the problems for any new joiners. And that's where this Geoharbor framework I developed actually solves solves the majority of problem. It means you are not dealing with any notebooks because you actually do the best. And any data engineers or data engineering team, they do certain 2 or 3 things basically day in day out. One, they actually discover the incoming data, means what are my data sources, so I can use for data ingestion purposes. And then they write some SQL queries. So how do I ingest that data? Or then and then how do I transform this data, and how do I save it somewhere else? That's what they do day in, day out. Of course, there are a lot of elements here, data governance and all those things. But nobody thinks about how this data will be making sense to business analyst or anyone else within that organization from data governance perspective. Let's say I'm a business analyst and I'm looking for, let's say order data in particular system. And I don't know what the data looks like. I don't know what the schema looks like, and it actually becomes a problem. So technical people, they are trying to solve the problem, but also not mindful about the stakeholders. And this Geoharbor actually forces you to start communicating to the stakeholders from day one. And that's where it actually comes with, I'll go back to this particular diagram. So you are creating notebook after notebook, and it is actually creating a notebook hell. So the particular data engineer or particular team, they know what this is inside, but it actually creates a massive technical debt for people joining in, or it actually becomes unmaintainable in a long run.
There's another term there, Rakesh, sorry to interrupt. Technical debt, can you define that?
Yeah, so technical debt, it means, okay, we are adding things day in, day out. And when it actually becomes a massive load of notebooks, then team is actually thinking about how do we optimize this whole process so we can minimize the notebooks, or we can minimize, or we can actually think about moving schema to some central place where we can start thinking about moving the SQL queries to central place. So there are two aspects. One, they actually start thinking about how to manage it better, plus how to reuse those queries again and again. And that actually creates a massive technical debt because they still have to work, plus they have to take time out to fix those technical debt. Now, from business perspective, I have come across the companies not willing to spend time into technical debts, which actually becomes a technical team's problem. So they have to work on the current requirements, plus they also have to eliminate that technical debt. And that's where the Geoharbor tries to solve this particular problem, and also talking and working with different teams and different customers. Now, as I was saying previously, and the context here is Spark ultimately. So Spark, there are different flavors of Spark here. So the Databricks has got Spark, but a bit of Spark, and then Azure Space, Azure Synapse Analytics, and then Spark, and then other MS Fabric and everything here. But ultimately, they are using Spark, right? So what happens in Geoharbor is that it is a metadata-driven data transformation, and that's where I was explaining about. I have seen solutions where a couple of vendors or companies they have tried to solve this particular problem, but the challenge I see is they don't care about how the current processes being set up in the current team itself, or how the CI/CD pipelines are there, or how the infrastructure provisioning are taking place. So just an example here, I was working with a customer, and the infrastructure guys, in this case, they were responsible to provisioning infrastructure. In this case, how to create Azure virtual machines, how to create infrastructures in Azure environment. And they were using ARM templates and Bicep for their infrastructure provisioning. Now, a particular vendor, they came up with this particular product. We were talking about meta-driven data transformation, but the problem was team, they need to reskill on because they had Terraform for infrastructure provisioning. So Terraform is a tool which actually allows you to create infrastructures in an automated way. It means it is idempotent. It means if you have different environments like dev, test, and production environments, you can create them consistently. And if you want to roll back, you can roll back in a very automated way. Now, so the other option was also the team that they were actually using Azure DevOps, which is for CI/CD pipelines. So how to run or deploy particular data platform, or how do I deploy data applications anywhere in Azure, and they were having different standards. Now, this particular vendor, they actually were using GitHub Actions. Now, no sync between how the current process works in that current team. So I see the same problem everywhere now also. So now I have tried to dismantle this through Geoharbor. So ultimately, this is just focus on how do you transform your data, and the consumers or the data platform team or data engineering team, they can continue use their own processes. So if they are using Azure DevOps for CI/CD pipelines and deployment, they can still choose to do that. If they are using something else like Bicep or Terraform for infrastructure provisioning, they can continue to use it. There is no new addition to an existing team. They don't have to reskill. I think reskill in the sense is that, of course, reskilling is good for taking care of platform and everything. But of course, once you introduce a new technology, it has different repercussions across organization. And it takes a lot of time, many months. And in that particular case, team started with a pilot with this particular vendor. After 6 months, they went nowhere. So of course, they tried to solve this problem through meta-driven data transformation, but they decided to scrap and abandon it because, okay, the number one, it doesn't fit our current processes because we are using XYZ and you are just coming with ABC, which doesn't work with us. The tool was quite good, but those kind of things actually create problems. And Geoharbor doesn't force you this. So Geoharbor is that I'm going to explain. So very basic example in the layman perspective is that you have knobs and different knobs. So any non-technical people, they know how to operate this particular knob. So you move it left or temperature knob. So if you want to reduce, you can reduce. If you want to increase, then you just have to move it right, and then you can actually increase the temperature in this case, right? So it is all about configuration, and I'm just comparing with knobs here. It is easy for non-technical people to understand how this actually works. It means you define configurations and not worrying about how to do things in a different way, because every data engineer is not writing their own way, number one. Second, when any new data engineer or any team member joins in the team, it is pretty easy to know the framework day one. And of course, Geoharbor, and I'm saying that within 4 hours, anyone who joins the team, they know how it actually works. Now, from data engineering perspective, what matters for most data engineers is that writing SQL queries and not worrying about any other else. Plus, it actually also about standardization of code. So code standard is consistent and the configurations are consistent. Anyone joining in, they know how to configure this. If they have some problem, they know where to look at. So they are not spending time looking into every notebook or notebook. If let's say if the notebook has massive lines of code, I'm not getting into all the code and everything, how it works. And Geoharbor actually allows you to do that. So what happens here is that in a very so I'm actually going to use a very technical word here, and I will come back to non-technical term. So Geoharbor is ultimately wheel file, and wheel file, just understand this is a package. For non-technical users, if you want to install anything, let's say installer, you actually download an installer, you double click and you install. You don't know how it runs in the background, but ultimately, let's say if you are a Windows user and you have installed MS Office, you install it and you have got MS Word, MS Excel, and all these Microsoft toolings, right? And it's the same here. So Geoharbor is basically a wheel file, which actually any Python programmer or any data engineer, they know about how to install it. And what happens also that since this is a meta-driven data transformation framework, and also the data governance inbuilt from day one itself, meaning first I'll walk you through what this is all about. So this is a very skeleton code here, right? There is no Python code, nothing else. What is happening is here is that, and I was explaining that the data engineers are actually what they are doing is from the data transformation is that where are my data sources, and I'm going to write some SQL to transform that data, and I would like to save somewhere else. Now, the other aspect that Geoharbor also solves is that the installing of any version is dependent on the data engineering team. Meaning, if Apache Sedona, comes with 1.9 or 2.0 version in the future, Geoharbor doesn't dictate anything. So data engineering team, if they would like to install or upgrade to the current version, that's up to them, right? So many times it also happens that the vendors can introduce a framework, but that is actually using, and they are forcing particular data engineering team to use that particular version. And if they are looking to upgrade to certain version, that facility is not available, and the vendor says, you know what, it's going to take a little bit of time, probably 3-4 months before we can upgrade. And the developers, they lose productivity. They just can't use the latest version in that case. So now from configuration perspective, how this works is that from data contract perspective, that's a schema. And this is Spark related schema, nothing else. Any Spark programming language, and I think anyone who knows Spark, they know what is this Spark struct schema is. This is just a data contract for any data source. It can be an incoming data source, and it actually can be outgoing data source. And also it actually validates whether what data you are actually trying to transform, if that it is actually compliant with the data contract or not through that particular Spark struct schema. And if you see at the top, and this actually creates a foundation for data governance. It means I'm actually writing about metadata of this particular data contract. So in case, let's say I have a different data governance system, and also the thing is that the Geoharbor doesn't dictate you which framework you want to opt for data governance. So let's say in this example, I want to choose Microsoft Purview for data governance. And from governance perspective, what happens? You have a couple of options. You actually want to know about metadata of data, the meaning of the data first. And if you have any query or something, whom I contact actually. So it actually forces you to define all this information. They are optional, but it actually dictates you to write and use the governance feature from day one. So it actually allows you to write everything here. So like it actually says, is this PII data? What is the classification here? What's the description of this data? What is the masking policy? It actually tells you to do that. So it means the data stewards, and any data engineer, they actually work with stakeholders to understand the meaning of data as well. Okay, the first thing. So it actually allows you to construct that data contract through the data catalogs. Now, the other aspect is that the jobs are simply, the YAML configuration. And I was talking about those knobs. How do you configure those options? And the option, so here in this case is that, and as I shown in the diagram itself, because this is Spark, and this particular framework, Geoharbor framework, can work across Spark platforms, meaning it can work with Azure Synapse Analytics, it can work with MS Fabric, and it can work with Databricks, it can work with on-prem Spark, that doesn't matter. So you actually define what are your sources, you just configure it, and then you say, how do I transform that data? And transformation can be inline, or transformation can be through files, SQL queries here. And what I'm doing here is that I'm actually writing those informations here. So what I'm doing, this is a simple SQL query. Any data engineer using Spark, they are just writing their SQL query here. So what you do, the YAML has got three things, right? You define your source or multiple sources. You define your transformation query, and you define where you want to store this data once your data transformation has happened. That's all. And from data engineering perspective, that's all three things happens during any data transformation. And it actually allows you to define, again, sources, transform your query, and then write. In this case, I'm using OneLake and MS Fabric. So that's the path it actually denotes here. And that's the path it actually denotes here when I'm writing data to OneLake. And OneLake is, just consider about this is a lake house, which is using Medallion architecture here. So bronze layer for raw data, silver layer for cleansing of data, and gold layer for analytics grade data. So what Geoharbor does is that, number one, you configure your jobs. So you discover your sources, transform your data, and saves. You define your data contracts. And when you define your data contract, you are actually saying that what are my data governance aspect also. So it actually allows you to define your schema here. And what actually happens is that when you transform your data and when you want to write to some other place in Lakehouse, let's say silver layer or gold layer, it actually compares your schema and see if you have got the right data which should go into that Lakehouse. And if it doesn't, then it throws an error and you need to correct your schema. So it actually gives you error in a very human readable format. So that's what it actually solves a particular problem. But I think the developers or data engineers, they don't consider the data governance when they start. And consider about, when I consult with big organizations, they have a chief data officer. And of course, that chief data officer is not going to look at these config files and SQL queries and everything, or any stakeholders. They just want to have a central place and see, have I got this? So I have got this data governance framework, let's say MS Purview in this case. They just want to search data and they want to use that data from self-serve analytics perspective. And this also allows you, in this case, is that, okay, you have got this particular data contract defined. You need to define certain properties here. Let's say if I have any problem understanding this data sources or data contract, who I contact, right? And this actually gives you a little bit more information aligned with any industry standard data governance tool. It could be, Apache Atlas, it could be MS Purview, it could be something else. But they all, talk about the same term: classification, glossaries, tagging, who is the owner, what's the description of this data, what's the meaning of this data, etc. Plus, it also allows you to create a view that where my data is traveling. So any data governance tool, they actually also tell you where my data is actually traveling. And this actually gives a little bit of more information. And it forces data engineers to talk to business stakeholders from day one. So they are not coming up once they have finished the project, but it's a kind of, we are starting this journey together. So I don't understand this data because the analyst or the project managers, they know the domain of that particular data. The data engineers might know or probably might not know about those data or those domains, but they help data engineers to explain those terminology of that particular domain itself. And it helps a lot when they start together.
Rakesh, I've got a couple of questions here, if you don't mind.
Yeah, go, please.
So I remember in the, promotional materials for this episode, you were talking about like a case study and like a real world example. I don't know if you were going to speak to that. Another observation I've got here, so I'm saying on the left, you've got the data lake zones, bronze, silver, gold. I'm also wondering if you're going to speak to those.
So bronze, gold, silver, they are lake house terminology. So how do you manage your data? And bronze means just raw data coming from, it could be OLTP sources, could be SQL Server, it could be something else. It could be Adobe Analytics data as is. So we don't do any data transformation when we are ingesting that data, which is bronze layer here. But once data transformations take place, they pick up data from bronze layers, let's say silver in this case, just the next chain of this, the next item in this chain. And silver layer is all about, cleaning those any, anomalies in that raw data. And sometimes you see many anomalies in the data. right? So let's say I have got null values, and then we replace with some sensible the business values there. We also, so it is so silver is layer is like an enterprise data. Any team or any person who is looking to view the enterprise level, very clean data, they refer to the silver layer. So they have just a little bit of transformation, cleaning of data. So they have all the business cases involved, SSN number, it's shown to be null. If it is null, we are replacing with default, or we are not ingesting that data in the silver layer at all. So those kind of business rules.
And a concept here that I appreciate is governed transformations. So they occur via a script. So for example, and you can just rerun that every time you get the next version or something of a raw bronze table. You run the same script to drop a field,
absolutely.
For example. This idea of governed transformation, I think, is quite powerful.
Absolutely. And then, the goal here is all about analytics grade data, right? So when we talk about analytics grade data, it means various data modeling concepts come into the picture. Some people or some team, they use Kimball architecture, Kimball modeling. It means dimensional modeling, talk about dimensions and facts. And they use some certain data modeling architecture. And the different teams they use, but primarily the industry standard Kimball architecture. So that's for goal layer analytics. So that is analytics grade data. Again, Geoharbor doesn't dictate if you have multiple gold layers. It could be gold 1, gold 2, gold 3. It depends on team to team. Also, it can be domain specific as well. Let's say I want to store HR data somewhere else. I want to store CRM data here. I want to store sales data here. So we can define domain, and it is just about data transformation here, and also managing how do we move data from point A to point B.
Okay, and that moving or those transformations happen with a so-called orchestration platform, do they? Like Apache, is it Airflow or Daxt or a Prefect?
Yes.
Am I getting that right?
Good example. So in this case, on this screen, I'm using Microsoft Fabric, which is using a pipelines kind of data factory, which is used for orchestration purposes. Now, the good thing about Geoharbor is that it doesn't dictate you what actually orchestration tools you bring in. It doesn't dictate anything. So it means if you want to use, Daxter, if you want to use Airflow, if you want to use something else, it doesn't dictate you. And here it is a simple orchestration layer that, okay, I'm ingesting data here, and I'm just cleaning. So we saw FHRS, food hygiene, data. That's UK government data here, and that's what FHRS here as a food and hygiene data. And what I'm doing is that I'm ingesting this data, cleaning this data, and then I'm actually creating a couple of other data here. But also, Geoharbor allows you to ingest spatial data using Apache Sedona. So once you install this Geoharbor, you don't have to worry about non-spatial and spatial data. Of course, in spatial data, you actually worry about line, polygons, and multiple other things, right? But Geoharbor allows you to do it from a single framework here. And that's where you see I'm ingesting this REST data, and I'm cleaning it, and I'm aggregating that data, and it is doing the same. It is using the same Geoharbor framework for spatial and non-spatial data engineering workloads in Spark.
Right. Just, again, continuing my role here as being completely shameless about knowing nothing about data engineering. You had a website promoting Geoharbor, and are you able to bring that up again?
Yeah, sure. Yes, that's that. Yeah.
If you scroll down, I think there was some sort of a case study or describing. Yeah, this one here in
this
purple.
one here, purple one. This one here. Yes.
I'm just wondering if you could speak to that a bit.
Absolutely. So, what actually happens in a traditional data engineering life cycle, and I have seen And I have been into data engineering space for many years now, but the trend is same everywhere I go. You know? What actually happens is that, and let me bring up that particular this thing. So consider that this is your workspace, and from layman perspective, workspace means this is a space where all the data engineers in a team, they are using to write their code, right? So if you see, I have got so many files here, and they are all notebooks. And how does they look is that they look like this. So this is a notebook. I'm writing something here. This is just, Geoharbor specific. So I'm using, so what Geoharbor does is that you only have a one notebook exposed, that's all. So in full Geoharbor framework, you don't manage any notebooks, nothing. In reality, what happens is that data engineers, they actually create notebook after notebooks. Notebook after notebooks. I have seen 1,000 notebooks here. Now, of course, when the project is massive, any data platform is massive, they are dealing with multiple data like Salesforce data or Adobe Analytics data, let's say data from SQL, order data, inventory data, etc., etc. What happens is that, and only inventory, only to build a data analytics for inventory, data engineers, they might write hundreds of notebooks to analyze inventory data. They might use hundreds of data transformations notebooks to analyze that data. And the problem is, if any new joiners join in, or let's say I'm an existing team member, I haven't done any CRM data analytics, and I'm looking into here, I'm saying, okay, what to look at because I don't know where is what, and I'm lost completely. Now with Geoharbor, you are not dealing with notebooks at all. What you are dealing with here is that these all configurations. You define your data sources because you are a domain expert. So you know what data sources you are actually after. Since you are a data engineer, you are only interested with your SQL queries. And Geoharbor doesn't dictate you how should you be writing a very production and optimized SQL query. So this is data engineer's job. And Geoharbor doesn't dictate it. Meaning also, if the Databricks has got a different mechanism to optimize Spark code and they want you to write Spark SQL in a very different fashion, it is up to you. So you actually write SQL queries here. You are not dealing with any notebooks here. Okay. And now, since this is a metadata-driven data transformation, it means the meaning is completely clear to me. So data catalog means I'm dealing with all the data contracts. Jobs means how do I define those sources? So where are my SQL queries and where those data are moving? I know it by looking at these jobs. I don't have to go anywhere else. And this and it is completely defined which things are going where. And any new joiners can start looking into this within a few hours. If you have to support any production issues, and if you haven't written your code yourself, you know where to find it. And it is a massive win for any data team because they don't have to manage first the notebook health. I'm not, writing or creating any notebooks. And number two, it actually allowed standardization across the data team. So you actually are writing your data transformation queries in a very predefined fashion. And you know the meaning of data catalog here, you know what the meaning of jobs, SQL catalogs, you know everything.
Sorry to interrupt. So if I don't know, I've got literally the world's most simple bit of SQL syntax that I'm grabbing the name of a table in my bronze zone, and I'm literally dropping a single field. I don't know. The field's name is, I don't know, field 2. So I have some syntax to drop field 2 from this table in bronze. So are you saying that I should save that syntax in the SQL catalog within this
Yeah,
Geoharbor framework
yes,
so that there are no
absolutely.
hidden orphan SQL scripts that only I know about? Any SQL development is made available to the whole team within this catalog.
Yeah, true. Now, another aspect of Geoharbor is that, let's say I have said this, the root folder is meta catalog. Again, it is configurable. And how? Because when any pipeline runs or any orchestration tool you use, it actually asks you to define few configuration. Like, let's say, what is this meta config container? And I'm saying meta catalog. Other team, they might name in a different way. They would say, I want to say meta and then underscore catalog, which is completely fine. If they want to say ABC, that's completely fine. Now, Geoharbor framework, it is going to look at only these patterns. Data catalog for data, so data contracts under data catalog, jobs under this, and SQL, all the SQL scripts are under data under SQL catalogs. It means you are not dropping your SQL script inside jobs. No way you will do this actually, okay? Because it's been defined in a very standardized format that, okay, all the data contracts go inside data catalog. That's why once we deploy Geoharbor, we give, a couple of hours training to the data engineers and team that they should be structuring those to make their life easy and their team members' life easy. So all the SQL scripts, they go inside SQL catalog. Jobs inside here and data contracts inside data catalog. That's all. So any new joiners, or if let's say I'm doing any production support and I don't know anything about inventory analytics, but I can see, okay, under bronze, I have got this inventory data contract. I can see this inventory job here, and I can see some queries here. Again, different teams, they'll be defining, let's say inside goal, they might have domain specific SQL queries, let's say sales, inventory, CRM, SAP, etc., etc. So it just, so we also help team how to define and standardize those folder structure also. And ultimately, it is just a folder structure. And the massive thing is that the use of AI here. And why? Because the other tool I have, we actually have developed here, I will take probably 2 minutes here. Because how you can be 10x productive here then. So, and it is integrated. So let's say this is Azure environment and you are not using any credential-based system, just Azure authentication here. And what happens? I'm just going to approve this request. What's happening is that now I'm not sure if you guys know much about Azure AI infrastructure in this case, but what happens in any LLM in this case is that you feed in information to large language models, right? And that's how it actually knows the context. So it is not your public data. The LLMs like ChatGPT and all these, they are large language models, but they have a cutoff date, means they are trained on public data sets until this date. But this data is your private data, right? So this Geoharbor XML, YAML files, SQL files, and your data contracts, they are your private data, right? So you can fully integrate within your Azure AI framework or Databricks AI framework, and then you don't have to probably write YAML just yourself. You can instruct AI that, okay, I have trained you on my data contracts, my YAML jobs, and my SQL script. let's say I have this inventory contract. I'm actually supplying you five columns, let's say inventory ID, date, and all this information. Create me a data catalog file, create me a job, create me a related SQL, and it can actually generate you. And that's why the idea is you have this information saved in your one lake or lake house. In this case, if you see, I have deployed this inside the lake house here in Beta Catalog. So I have defined here, I can instruct my AI to train on this data, and then I can ask question, create me. So I don't have to, next time, I don't have to write all JSON myself. AI can do it, okay? Yeah, I don't have to probably configure YAML myself. Of course, once AI generates it, you might be doing modifications here and there. AI might generate SQL scripts for you, and you say, you know what, this is not very optimized, and I can do, more or better than you. And then you actually do it. So this actually goes beyond data platform, and you can have AI integrated as well, also.
There we go. Of course, you need to have a reference to AI, so that was convincing.
Yeah. Yeah, but of course, you can train on your private data, which is also one of the use cases here. So what happens, because AI is generating everything. So if I have this particular thing stored somewhere and I can train on this data, and AI can answer or create things for me. Okay, so that's also an element here. But that's how it allows you to manage spatial data and non-spatial data both through one platform. It doesn't dictate any process you need to change as a team, as an organization, nothing. It just brings you a particular framework, and you build your foundation around that particular framework. Framework doesn't dictate anything. No, it just doesn't dictate anything here. It makes your life easy how to organize your data platform, your data engineering code or repository, however you want to say it, in a very nice and standard format. That's all. And avoid the notebook hell. And this example I've clearly written, I've seen those use cases myself. New joiner coming in, and they are scratching their head after 3 weeks and 4 weeks, where to find things, I don't know. And Geoharbor completely eliminates that particular problem for any team.
Okay. There was a canvas you had with a diagram. Yeah, here.
Yeah.
So on the right, this is the Geoharbor way. How much of this have you gone through, or what's not covered in the remaining 3 minutes?
Well, of course, I have explained this is all about meta-driven. So how do you define JSON, SQL, YAML? Of course, here example is Azure pipeline. But if they are using GitHub Actions or source version control SVN, they are free to do it. So Geoharbor doesn't dictate. What it does is that I have got YAML, SQL, JSON, and I want to deploy to storage somewhere. So pipeline can pick up those metadata, catalogs, queries, and everything, and they can run within that Spark framework itself. And then you can say, let's say in this case, Delta Lake, I'm saying, or one lake in this case, but it can be, the blob storage of your choice. It could be Amazon S3. It can be Azure blob storage. It could be Amazon S3. It could be Google specific storage also. That's not a problem. So Geoharbor doesn't dictate anything. It just requires a Spark, and it has got one package file with couple of only 2 jar files. With Apache Sedona expects you to deploy in your environment. That's all. And then you build your metadata driven transformation files from that point onwards. Meaning in this case, though I'm running Geoharbor here, but I have got this package file deployed within this environment so it can understand that's where the Geoharbor is running. So let's say in this case, I'm saying Geoharbor is DB, so build harbor and sell. And then what it is doing is that ultimately it is just passing that YAML information. So the YAML we saw here, it just passes this YAML to the particular code, and that's all. It actually picks up your SQL script, it picks up your YAML configuration, it picks up your data contract, and it does all data transformation in the background. And you are not managing any notebooks here, nothing.
Okay, so I guess this brings us to the role of a data engineer. They are the ones that maintain a system, and this, what you've been talking about, is in the context of a team of people who do this. They maintain a system which ingests, inhales streams of raw, unprocessed data, warts and all. And because of those warts, there are zones in the data lake beyond bronze. This is about an organized approach, I guess, for these governed transformations, so that any progress individuals on the team make in terms of new scripts are shared and can be picked up by other team members. Is that it? All the way through to whatever zone means the data is fit for other roles in the data team, like data analysts, data scientists, ML staff, to then pick up and run with those data sets in those zones that the data engineers are prepared using, for example, this framework to do all of that in an organized way. Am I getting any way towards a useful summary?
I think that's a nice summary. Absolutely. So it actually makes data engineer's life easy, and no notebook hell. You are not going through notebooks and finding what's the problem, where are the SQL scripts, where are my data contracts. I'm not scouring through all those notebooks. I know where to look at. If they're pretty organized, any new joiners that they can join and they can start contributing within few hours itself. And that's a massive win for any team and any company, to be honest, from productivity perspective.
I don't want this to be end, Rakesh. I love having discussion about data engineering in the context of geospatial, so the more the better, and let's find another topic.
So cheers. Thank you so much, guys. Have a nice
Bye.
evening.